Hello everyone, welcome to the video lecture series on Internet of Things. In today's lecture, we are going to study second unit, that is sensor network. In today's lecture, we are going to discuss sensor. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us discuss the content in unit 2, that is sensor network. In this unit, we are going to discuss definition of sensor, types of sensor, types of actuators, example and working, RFID principles and components, wireless sensor network, its history and context, the nodes, connecting nodes, networking nodes, WSN and IoT. Let us first discuss the sensor definition. Sensors are special kind of transducer which can convert some physical phenomena into electrical signals. The electrical signal can be recorded by computing system. The recorded data can later be converted into meaningful information on which decisions are taken. Sensors are small electronic devices. Enormous type of sensors are available to sense diverse kind of physical phenomena and environmental conditions. Sensor can be as simple as temperature sensor and can be complex as high-resolution interplanetary cameras. There are many examples of sensor around us. Many electronic devices in common use consist of sensor. One smartphone can have as many as dozen of sensors. For example, cameras, light sensor, touch sensor, proximity sensor, accelerometer, etc. More examples of sensor are IR sensor, heat sensor, pressure sensor, motion sensor, gyroscope, etc. Sensor also provides actuation functionality. Such sensors can detect called electrical or electronic actuators. Sensor can detect signal but actuators can generate signals. Types of sensor. Sensors are of various types. They can be classified in categories according to the parameters they are designed to measure. Following are the types of sensors: mechanical sensor, thermal sensor, radiation sensor, chemical sensor, biological sensor, military sensor, electrostatic sensor or magnetic field sensors. First, mechanical sensor. Mechanical sensors are designed to sense physical phenomena like pressure, force, and position. Inertia and flow sensor can also categorize as a mechanical sensor. Thermal sensor. Thermal sensors are designed to detect the heat, temperature, and heat flow sensors are the examples. Radio sensor. There are radiation intensity sensor. These are radiation intensity sensor. This sensor measures intensity of the radioactivity in the surrounding or in substance. Chemical sensors. Many sensors like humidity, gas concentration, acidity or base measurement, ion, etc. also falls under the chemical sensor. Biological sensor. These sensors are special sensors designed to sense biological conditions like presence of biological organisms, virus and bacteria, toxic substances, etc. Military sensor. Different kind of sensor may fall under the military sensor. They are used for military tracking, battlefield surveillance, etc. Electrostatic sensor or magnetic field sensor. These are sensors to detect the magnetic field. Such sensor can be used to detect the explosive, bombs and other electrostatic or magnetic fields. Now, types of actuators. Actuator converts the energy into motion. In IoT, the end result is achieved using the actuators. Actuators can be motion controllers. They are mostly mechanical devices which controls other devices like water pumps, electric switches, water sprinklers, fuses, etc. Actuators have many criteria to get classified. One possible criteria for actuator classification is based on the energy they require to generate motions. Types of actuators. Actuators in general classified into following categories: electric or electronic actuators, hydraulic actuators, thermal actuators, pneumatic actuators, First, electric or electronics actuators. This is most common type of actuators for IoT application. This can switch the device on or off. It can generate motion too for achieving the desired result. It may require external power source like battery. Hydraulic actuators. The source of energy here is a liquid to generate the motion. Thermal actuators. As name suggests, it uses the heat as a source to generate the motion or task targeted to achieve. Pneumatic actuators. The compressed air is used to achieve the desired actuation. Figure shows the abstract view of IoT with sensing and actuating. Sensor, actuators, network and computing devices become a part of smart system to implement the IoT. Sensors and actuators plays an integral role of such system. Example and working. The basic abstract view of IoT with sensing and actuating devices is shown in figure. In figure, IoT-based basic service placed at the top. This stack of service needs the data transport service to achieve system objective. Data transport service can be based on non-IP based communication model, IP based communication model or on future networks. To understand the working of sensors and actuators, take the example of automatic fire detection and sprinkling system. The system has fire or heat or smoke detecting sensor that sense and send the signal to control center. The control center has the necessary rules written in the code to take decision based on the thresholds. Based on the decision taken, control center send command to the actuators. Actuator works in a reverse cycle comparing to the sensor. Actuator sends the electric signal and converts it into motion. That motion is used to turn on the water sprinkles. The entire flow of operation from sensor to actuators for such fire detecting and sprinkling system is shown in the next figure. Figure shows the control flow from sensor to actuator. The sensor is the temperature sensor that detects the temperature and it sends the signal to the control center. The control center sends command to the sprinkler and automatically sprinkler turns on and put flame out. The role of sensor and actuator can also be understood by taking example of smart irrigation system. The primary objective of smart irrigation system is to develop an IoT system which can collect data related to soil condition and can automate the process irrigation, that is amount of water flow. This system is intended to detect moisture level in soil using the required sensor and control the amount of water to be used for irrigation using automated valves.